This is section 11.5, Recursion and Iteration. A recursive formula is a formula in which every term will be determined by one or more of the previous terms. So, in other words, you're not going to be able to find one term unless you have the terms before it. We have a couple of formulas we're going to be using. We have a recursive formula for an arithmetic sequence, which is a sub n equals a sub n minus 1 plus d. And d is going to be the common difference, which just means how many is between each term. So between like 5 and 9, the common difference would be 4. Our geometric sequence is a sub n equals r times a sub n minus 1. And r is going to be the common ratio. So what am I multiplying by in this case, or what am I dividing by in this case to be able to get to my next term? So in example 1, we're going to be using a recursive formula. It says find the first 5 terms of the sequence in which a sub 1 equals negative 3 and a sub n plus 1 is equal to 4 a sub n minus 2 if n is greater than or equal to 1. So first of all, we want to start off with our formula, which is just a sub n plus 1 equals 4 times a sub n minus 2. And we know what a sub 1 is because they gave that to us. So for the first term, we're going to go ahead and say, okay, n we know is 1 in this case for the first term. So we can go ahead and mark that over here. We're going to say n equals 1. And then we're going to go ahead and plug in what we know. So we have equals 4 times a sub 1 in this case is what we're going to use because we're using n equals 1 minus 2. So now I can go ahead and plug these things in. Since n was 1, I plugged in 1 right here for my n value. And then I also know this a sub 1 value. So I'm going to go ahead and plug that in. So I have a sub 2, because 1 plus 1 is 2, equals 4 times my a sub 1 value, they gave that to me right here, is negative 3 minus 2. So now all we're going to do is evaluate this. And I'm going to write our answers over to the side. They want the first 5 terms. They gave us the first term. A sub 1 is negative 3. So a sub 2, which we're solving for right here, we have 4 times negative 3, which is negative 12, minus 2. That's going to give us negative 14 for a sub 2. So now I'm ready to find, I have to find the third term, the fourth term, and the fifth term because they want all of those. So now I'm going to go ahead and use the information that I have to find my next value. In example 2, we're going to write recursive formulas for the sequences. And the very first thing we need to do is determine if the sequence is arithmetic or geometric. So we're going to actually have to look at these terms and try and figure this out. So we ask ourselves, okay, how do I get from 2 to 10? Well, there's a couple ways. We could add 8, and we could also multiply by 5. So then we have to go on to the next one. Well, how do I get from 10 to 18? Well, in this case, I'm only going to be able to add 8. Okay, so then I want to check and make sure that adding 8 is what happens every time. So we know that 2 plus 8 gives us 10, plus 8 gives us 18, plus 8 gives us 26, and plus 8 gives me 34. So in this case, we're adding. So we want to go ahead and classify this one as arithmetic sequence because adding means we're doing arithmetic. And so I'm going to go ahead and write our formula down that we'll be using. Our arithmetic sequence formula is a sub n equals a sub n minus 1 plus d. And remember, d is that common difference. What are we adding each time? So we know that we can go ahead and plug some stuff in here. We have a sub n equals a sub n minus 1, and then d, that difference, we were adding 8 each time. So we're going to put plus 8. And that's actually all we're able to do here. So that's going to be our formula. This means I can find anything, any term in this sequence by using this formula. We're going to do the same thing for B. It says that a sub 4 equals 108 and r equals 3. So since they're giving me r, I know that this is going to be a geometric sequence. So our geometric sequence formula is a sub n equals r times a sub n minus 1. Okay, so now since they gave us these things, we can go ahead and plug them in. So we have a sub n equals 3, because that's our r value, times a sub n minus 1. And that's actually all that we're going to need to do on this one as well. So now we have this formula that we could use to be able to figure out any term in this sequence. Iteration is the process of repeatedly composing a function with itself. So in example 3, we're going to actually be doing this. And really this is the same process as what we've been doing. The notation is the only thing that's really different about this. So on A, it says find the first 3 iterates of x1, x sub 2, and x sub 3 of f of x equals 5x plus 4 for an initial value of x sub 0 equals 2. So the first thing we want to do is say, okay, x sub 1 is equal to f of x sub 0. And this is just the notation. Your process, like I said, is still going to be the same. So what we're going to do, we're going to take our formula that they gave us. They gave us f of x equals 5x plus 4. And I'm going to go ahead and plug in that 2 that they gave me. So I'm going to have 5 times 2 plus 4, which is going to give me 14. Okay, then I also know we have x sub 2 is going to be equal to f of x sub 1. Okay, again, this is just how we write this. We're still doing the same process. So just like before, we're going to take what we just got as an answer and we're going to plug it in to our next equation. So we're going to have 5 times 14 plus 4, and that's going to give me 74. Then we're going to iterate the function again. So we have x sub 3 is equal to f of x sub 2. Again, same process. That 74 is going to get plugged into our new formula. So we have 5 times 74 plus 4, and that's going to equal 374. And so they asked for the first 3 iterates. Our first 3 iterates are 14, 74, and 374. So in example 2, we're going to be doing the same thing. We're going to take our formula that they gave us, f of x equals 3x minus 1, and the first thing we're going to do, we're going to take that x sub 0 equals 5 that they gave us, and we're going to plug that in. So we have 3 times 5 minus 1, so we'd have 15 minus 1, which is 14. Now we're going to take that value and plug it into the equation again. So we have 3 times 14 minus 1. And we're going to go ahead and solve that out. And that's going to give us 41. Then we're going to take that value and plug it in again because it asked for 3 of these. So we're going to have 3 times 41 minus 1, and that's going to give us 122. So our first 3 iterates, which is what they asked for, are 14, 41, and 122.